go ahead and get started.
Fantastic. All right. So we have us here, and you can hear me all right, right?
Yep.
Wonderful. Great. All right. Well, we'll kick things off. Thanks everyone for tuning in. And it looks like we'll probably still have a few more logging in as we get started. But yeah, we're here today, obviously, to talk about an alternative to IPA in additive labs in general, but then also very specifically in dental labs. So I'm here with Post-Process Technologies. I'm really happy to be presenting with Mike Wang at Proto3000, and then we'll have some guest speakers, special attendees here. So we'll get right into it. Yeah, so like I said, I'm with Post-Process Technologies. I've been here for about 7 years. So I have a mechanical engineering and application engineering background. And currently I work in business development and channel partner relationships. So I get to work with great companies like Proto3000, but still have some good interaction with our end customers like Schell Dental that we've been working with over the last few months. So yeah, Mike, I don't know if you want to give a little bit more of an intro to the rest of the team.
Yeah, I am a former dental technician, and I think something that's really important to us as Proto3000, as I've been on both the receiving end of a sales pitch, is actual feasibility in the lab space. And so the gentlemen over at Schell Dental Ceramics are definitely are on the forefront of the most forward-thinking labs. They're very concerned with how to improve workflows and how to be one of the safer spaces for their dental technicians. And so we brought the solution to them. We've worked with them with the Demi 430 at their lab, and I wanted them to give their experience to other dental technicians and lab owners. So with us today, we have Jamie Schell, who's one of the co-owners of Schell Dental Ceramics, and Evan, who is the primary operator for the printing in the back. If you guys wanted to just give a quick background on yourselves.
Yeah, sure. Yeah, Jamie Schell, my brother and I have had the lab here in Kelowna, British Columbia for about 30 years. The last 10 or 12 years has been quite the shift. Digital has been, it's been really fun. Hard to stay current though. Everything's changing so fast. This product and knowing Mike bringing it forward is just kind of the next step to, I think, what's needed. And something that's relatively new and probably not for very long. I think it's something that's going to be everywhere soon.
Hey, I'm Evan. I have a background in mechanical engineering, and I deal with most of the equipment here at Schell Dental. I've been here for 2 years, so yeah.
Awesome, thank you. And then Mike, I don't know if you want to go into a little more detail about yourself.
So like I said, I'm a former dental technician. I worked in a in-house prosthodontic office from 2010 to 2020. I want to talk about why we're really passionate about post-process here. I'm sure a lot of technicians on this webinar right now can probably relate to this. I did same-day repairs and hard relines, and I was smelling all of these chemicals day in, day out. And actually, funny story, I asked for a commercial-grade fume hood during one of our renovations, and what I ended up actually getting was like a little bathroom fan right above my workstation. And so I'm very accustomed to smelling all these chemicals and essentially being high at work just cold cure acrylic. So with the advent of 3D printing, IPA, it's such a powerful smell, and it's definitely not a great work environment for technicians. And this is an emerging technology, so it's something that we're not yet familiar with, and maybe the adverse effects will show up many years from now. We want a more safe environment for dental technicians, but there are other auxiliary benefits to this technology. So that's why we as a company feel very confident with this product, and we are really pleased with some of the feedback we've been getting from Schell Dental Ceramics. So
great, it's wonderful. And yeah, so just a quick overview of what this presentation will look like. We'll take maybe another 20 minutes or so and go through just an overview of the solution and some alternatives to IPA when it comes to resin cleaning. So it's anything for SLA, DLP, DLS, HPS, any of those, photocurable resin printing technologies, any methods that you want to get away from using such a high volume of IPA. That's, what we'll primarily talk about. And then we'll go into a little bit of a deeper discussion with Jamie and Evan. And so we'll kind of talk about their experience so far, being able to use a DEMI system with IPA replacement for their cleaning. And then we'll leave some time for question and answer at the end. So if anyone has any questions as we're going along, I know myself, if I don't write it down immediately, I will forget all of it. So just feel free to drop questions in as we're going along as they pop up, and then we'll be sure to address those at the end. So post-process, what do we do? We're a company that's been around for about 11 years now. And our founder, he worked in the additive field for many years before starting the company. And he really saw, firsthand in a lot of industrial, dental, and medical labs that we have all these companies making great 3D printers, and we have these great parts coming off of the printer, but there's this black box that happens in terms of post-printing when the parts are, come off the printer. And there's a lot of manual labor that goes into it, whether that's removing support material with, tools, or using water blasting, or manually scrubbing with isopropyl alcohol, to surface finishing and smoothing the parts. And that's just something that was, you have this digital thread of the part that you design, the part that you print, and then it totally falls off when it gets to the post-printing step. And so, the goal was to focus entirely on the additive market, and bring solutions where you have a connected and a smart, intelligent solution to reduce costs, reduce that labor and bottleneck, and then increase visibility into what you're doing for that post-printing step. And so, like I said, we'll be talking primarily about cleaning excess resin off of parts today, but post-process, we also have solutions for polyjet and FDM support removal, some faster, safer solutions for that. We do depowdering for polymeric parts. And then we also have surface finishing solutions for metal and polymer parts, for anyone that's doing other types of printing there. And so the reality of, what we see today, and it's, things are improving, but today in the market, companies are getting one 3D printer, and you're able to process parts that come off the printer. But as you add more printers to your lab, you start seeing these bottlenecks where the parts aren't customer ready coming off the printer, and there's a lot of steps you have to take to get those parts clean. And so this is the problem that we're addressing with these parts, or with these machines. And these are just some pictures showing a lot of the traditional methods that are currently in use to address this highly manual, highly inconsistent process of post-printing. So usually what we see is these 3D printing companies are great at making printers, great at producing parts, but their focus isn't really on post-printing, nor should it be. They make great printers. And so what happens is you port over these solutions that kind of work from traditional manufacturing and try to make them work for additive manufacturing and 3D printed parts. And so what you get is a lot of manual intervention required. You get solutions that will damage the parts. And so you have to be reprinting or fixing the parts, after they're cleaned. And so our goal was to, make something that is specifically focused on AM, so you don't have to deal with all that. So what we tend to see is existing solutions are time consuming. You get inconsistent results. The breakage rates are usually pretty high. And all of these things roll up into being very expensive. So for anyone that tracks the Wohlers report, or any post-print surveys that post-process puts out, we see that a couple years ago, it was an average of 27% of the part cost was rolled up into the post-printing. And we're seeing, every year that cost is getting higher because people are producing more parts and just don't have any sort of automated way to clean them. And obviously with IPA, there's a very clear and present safety concern. So that's an issue with that, as well as some other methods of post-printing. And so it's just not a sustainable way to approach business, because there's not enough people to fill the jobs that there currently are, let alone, trying to double your workforce to keep up with the demand. And so the post-process solution for, especially for resin cleaning, is a combination of hardware, software, and chemistry. And so, we kind of refer to it as a three-legged stool of the solution. You need all three legs of it in order to provide the full solution. So the DEMI systems that we have for resin cleaning, they have the hardware that includes ultrasonics, pump, heat agitation, cooling, along with software on board that controls all those components. So you're able to make sure that you're processing the parts quickly, you're able to batch parts, but you're not going to damage them, and you know when the cycles are going to be done, and you don't have to be doing that manual intervention of scrubbing or cleaning out small channels there. And so the third leg of that stool is the chemistry side. So at post-process, we have our headquarters in North America are in New York, here in Buffalo, New York. And then we opened up our offices in Europe about 5 years ago. And so we have all of our hardware, software, and chemistry engineers in-house. And so they develop these solutions in conjunction with each other, which is why they work so well. And so on the chemistry side, we really strive to make solutions that are faster, safer, and last much longer than what is currently on the market. And so all these things, together create a number of different benefits for our customers. And there's usually anywhere from 5 to 10 benefits that we see that come back on surveys and reports that we do. But the top 4 we usually see are the improved safety of both the technicians, engineers, as well as the parts, damaging less parts or fewer parts as you're processing them. We see increased consistency because you're not reliant on everyone on your team to be able to process a part exactly the same. So automating and batching allows you to take the guesswork out of, are we going to have a good part to send out at the end of the day? And then as we discussed, the increased throughput is one of the other big benefits, where there's just such a large bottleneck when one person has to touch every single part in order to clean it off or to smooth it off to be ready for the next step in your process. And then the productivity side of it. These things all combine to really reduce your overall cost while increasing the safety and sustainability of the process and your company as a whole.
I want to chime in on this part as well. So as a vendor, it's important to us that we bring a product to market that addresses very specific needs. Now, we actually met with exactly 4 labs to see what the viability would be of this in the workplace. And each commercial lab came back with 4 separate concerns, which is exactly what was outlined here. So right off the bat, Schell Dental Ceramics were very clear up front what they wanted out of this, which was we're really concerned with the safety aspect of this. Having a big drum of IPA in the lab doesn't feel safe. Also, the fumes that are coming out every time we walk past the room, they were very clear on that. We met with another lab that cited prolonged, dipping of the models in IPA, giving inconsistencies in their tolerance report. So they were saying, if it's all dependent on the work or on how long it's been left in the IPA, but we're getting almost like degradation of the model. We met another lab that talked about a bottleneck. They have 4 prints that come off of their 4 printers, and they have a really, really small wash station. So you're standing there, you can't really mix the different resins, and you're putting them into really, really tiny baskets. So you have a guy standing there that's putting them in, moving them over, and it's just a lot of manual labor that's not necessarily required. And the final lab basically just flat out told us, we're spending a ton of money on isopropyl alcohol every year, and it's not good. We don't want to be spending this. Is there a cost-effective alternative to this? So this solution, and we're going to get to the next couple of slides, actually addresses these 4 primary needs, but it's something that a lot of different dental labs are going through right now. So
yeah, absolutely. Yeah, it's interesting to see the different aspects of the solution that are more important to different labs. But they're all good, and they work together to just provide the full solution there. And so this is just a note on our software. So we talked about the onboard software on the machines. That's our automated software. And so that's what your operators are going to be using day to day, where depending on the machine, it is the software all looks the same. So like the look and feel is consistent from machine to machine. So it's very easy to adopt, a larger system if needed, or, more small systems if required. But you're able to run very simple cycles. It's just like a play, pause, stop type cycle there on the Demi 800 and above. There are save and store recipe options. So you can have recipes for different materials, or you can have recipes for different size geometries, or if there's parts that have internal geometries. So a lot of kind of mass customization, which is what's needed for additive here. But across the board, what you're getting is a software that allows you to run these machines and still, maintain this 5 to 10 minute cycle time to make sure you can plan out and get your parts out the door as needed. And then a note on connected, that's just our higher level software that can connect into our different machines. So if you're using any sort of fleet management type software, this can, you're able to run machines remotely, stop them remotely, get any sort of notifications from the machine directly to your desktop, and you can have it send you automated email reminders or notifications or text notifications for when cycles are complete, or if there's any sort of upcoming maintenance that might need to be done. And then this is pretty useful for medical and dental. You're able to record and track like quality control and quality assurance data. So if there's any sort of issues with parts down the line, you can look back and say, all right, we know exactly how these parts were processed. So, for resin removal specifically, IPA, in North America, we see 90 to 99% of customers and dental labs are using IPA to clean parts these days. In Europe, there's a lot more kind of alternative options like the TPM that requires a lot more scrubbing. But for North America, this is a lot of what we see. And so the issues that there are, which is this is no secret, IPA is a volatile chemistry. So it's the worst of both worlds, where you usually need some sort of manual intervention, but also it's this chemical that this solvent that you don't want to be standing above, in front of, without significant ventilation there. You'll get inconsistent results and damage or warped parts using IPA. So part of that is a result of IPA saturating so quickly that it very frequently comes to a point where you're trying to clean parts in dirty solution, and so you're never going to get that part fully clean. So then when you go to cure it, you'll see some areas that were not properly cleaned, and that can create issues down the line. And then as a solvent, IPA is just a pretty aggressive chemistry. So leaving parts in for too long, especially depending on the material you're printing, can damage, warp, and create issues for that end product you're making. And then solvent longevity, IPA, it will only saturate a certain amount of resin before it's used. Our PLM 403 detergent that comes with the Demi system, it can basically dissolve 10 times more, up to 10 times more resin than IPA can. So you're not at a point every day or couple days or every week where you're trying to use dirty solvent to clean some part. And then, like we discussed, the expense is becomes pretty high as you add printers and are cleaning more parts with this. And so these benefits all combine to make up improved solutions where you have a safer and more eco-friendly lab work environment. And this is, I've talked with Mike about this before. Our fastest selling systems, from like first contact with a customer to when they wanted it in their lab, has really been very intense immediate need from a safety perspective. So like just a quick side story. We had one customer that they were using IPA in their lab. and they had a distillation system and quite a bit of IPA around. They actually had an explosion in their lab, and the manager of the whole AM area was sitting on a stool nearby, and so it blew him against the wall. He was okay, luckily. I hope. So far everything seems fine. But the next day they were calling us up and they're like, hey, we need to get something in house. We're not allowed to use this anymore. And especially as customers are ramping up their volume, you're using, a lot of times half a gallon or a gallon, just a couple liters of IPA is not necessarily an issue, but as you're storing, dozens of liters of this, if not more, that's where you create some issues. And yeah, so then also the elimination of labor. This is something that has come up a lot. We see in North America and in Europe, where such a high percentage of the teams in dental labs are at a point where, in an age where they're looking to retire in the next couple of years. And what you guys do in the dental world is such a craftsman type skill, and you don't have enough people that are filling those roles. And so going digital is really the only way to make sure that we can meet the demand that's required. And the need for improved dental solutions is also increasing, just because we have aging populations. We all drink too many sugary coffee drinks, so that's not great for our teeth. So there's a lot more need there as well. So those two things combined, there's just a divergence between available labor and what needs to be done. And so from a repeatability perspective, you get this repeatable and consistent solution where you can batch parts and you get consistent results is very important. And it's helpful, from a management perspective, knowing that you're going to be able to meet the demand. And from like boots on the ground perspective, we've all been a part of teams where we can't keep up with what needs to be done, and it is you burn people out, and so you just get employee turnover, and then you're just constantly cycling through team members that need to be trained up, and it makes it tough. So these are the systems available for this resin cleaning solution. Starting on the left, we have the Demi 430, and that's what Schell Dental has. Which these all internally use the same technology stack, but different footprint, different processing chamber, and some different fixturing options here. So the Demi 430, that's the most common one we see in dental labs. But for mid to higher volume, we'll see the Demi 830. That's just a larger processing envelope, but you still have the ultrasonics, the heat, the pump, that agitation, as well as the cooling. And then the Demi 910. The next one over there, it's the same size as the Demi 830, but that was actually designed in conjunction with carbon. So you open up those doors, the lid on the top, and you have a few different fixturing options where you can actually just attach in multiple carbon print trays, build trays there. And so you can clean the parts right on the tray with that system specifically for carbon. And this way you can, you're able to purchase the machine and own it outright versus having to do any sort of leasing type program. And then any of the other systems, we do have customers, I think, including Schell, that are cleaning the entire tray with the parts all at once. So there's some different ways to make sure that in there. And then the largest system we have here, the Demi 4100, that's not something we usually see in dental labs, but for anyone joining us, we have quite a few participants today, anyone joining us from the industrial commercial realm and side of things, if you're using any sort of 750, 800, 850 millimeter build trays, those all fit into the Demi 4100. You can actually use the cart you use to load and unload the printers right into the 4100. It has a lift that drops the tray and parts down into the bath, runs a cycle, lifts them back up, allows them to drip off there. So that's the general lay of the land when it comes to cleaning the parts in the systems. So just a little cross section of the internal portion of the machines, just so you can see what's happening. you can see there's the fluid flow, the pump agitation, combined with the ultrasonics, you can see on the right side, and then there's the heat and the cooling in there. So this basically allows you to put a bunch of parts in all at once. It will move the parts around, clean the fluid throughout the parts, to, you know, eliminate any sort of issue with just, you know, cleaning one side of a part, or, you know, having parts that are just like stuck together there. So you're able to consistently clean those parts in the system without having to, you know, lift a basket up and down or shake it around, or, you know, run pipe cleaners through at all. And so this is just a snapshot of kind of an average of what we see for a traditional process for someone using IPA or a combination of TPM or PPC cleaning compared to when they use a post-process system. So usually what we see is that overall cycle time is reduced with the post-process system. It's definitely more consistent, and then a reduction in the overall technician time. And depending on the materials you're running and the type of parts you have, and whether you have a rigorous system in place for replacing your IPA regularly, you can have variations of that in your traditional process, but it's just very repeatable and consistent with the DEMI system, and you don't have to worry about parts being unclean parts coming out. And we have ways of testing that saturation level in the DEMI, so you can be aware of how close you are getting to saturation before you would need to swap out, versus just you know, waiting until you have dirty parts. Or, you know, the other side of the coin is swapping your bats out too soon, which is another reason why people end up using a lot of IPA. And when you dig into that, you know, IPA cost, it ends up being pretty high. And here's just a few pictures showing the differences in those processes. The traditional process is usually quite manual. You know, you may have parts being cleaned in trays, in ultrasonic tanks, or beakers that are inside of an ultrasonic tank. But either way, you're just cleaning a few parts with usually higher touch points, as compared to the post-process method, where you can throw a lot more parts into a single basket or your entire build tray into the basket and clean that part in 5 to 10, or that tray or parts, 5 to 10 minutes, and it's very consistent. Where you can go months and months with the same bath versus, you know, swapping out your IPA daily or weekly or bi-weekly there. So you're going through a lot less.
Yeah, I can chime in on this slide. So this is a actual photo from in Proto3000's boardroom, just to illustrate the different sizes. So on the left-hand side is what we have been using up until we purchased a DEMI 430 for ourselves and put it in the back, in our back warehouse area. We were using a twin tornado. I'm pretty sure most labs probably have seen or have one for themselves. It's a really great small unit, but you can see the two small baskets there for the clean and the dirty bath are just quite tiny. The DEMI 430, not only are there, you know, the auxiliary benefits of it being, you know, the less of the fumes that you're inhaling, but the actual amount of models that you can fit into the tray is like, it's ridiculous how much more production we can do. And we do backup printing at our facility, and so this actually has application for us. So I want to extend this to anybody that's local. We're based out in Vaughan. If you want to see this in action, or you want to come by and just check it out, you're more than welcome to. We're going to be installing it sometime next week, and we're happy to host anyone here if they want to come by, check it out, try post-processing a part, just see the general workflow.
Nice. Yeah, so moving on, this is a little bit technical, or I guess detail oriented, but I'll keep it brief here. But this is just, you know, from a safety perspective, comparing the PLM 403 detergent we use in the to isopropyl alcohol. So you see a PLM 403 on the top and then the IPA down below. So if you look at the third column over, you can see the vapor pressure there. And so the PLM 403, the vapor pressure is 0.2. compared to IPA's 33.1. And you can see obviously that's a order of magnitude higher for the IPA. And so vapor pressure, for anyone else that might have had to look it up, like myself, years ago when we were first talking about this stuff, that's basically the tendency of a liquid to turn itself into a gas. And so what that means in your lab is PLM403, you can leave that in your demi, even at temperature, for weeks or months at a time, and you will have minimal evaporation of that. So the detergent stays in the bath. Whereas the IPA, which is a much more volatile compound, that just wants to go up into the air. And so, after a week, your cup of IPA that was sitting out, even at room temperature, might be down to 50% after a week. And so that is this volatile organic compound that's going into the air that your team is breathing in. And there are a lot of states these days that are limiting IPA usage and the volume of IPA that can be in lab. And in Europe, we're seeing a significant reduction in IPA usage. A lot of areas have banned larger amounts of it for these reasons. And so, not only is this bad for us to breathe in, it's also something that creates that environment where, with the wrong, spark, or, something that comes off of an electrical device, you can have, a fire or some sort of explosion, which is, what we've seen before. And that leads us right into the flashpoint, which, ties into that safety aspect of it. For PLM403, the flashpoint is 104.4 degrees Celsius. So well above anything you see at, in a facility, or, in a machine that you'd be running this in, compared to IPA's 11.7 degrees Celsius, which really that means at room temperature, IPA is at a temperature above its flashpoint. So that's why it's recommended for, anything more, I think it's a few liters, that you have, full explosion-proof electrical, and any components you have in that room, should be explosion-proof or ATEX as well. So those are the, biggest things to be, looking at this. And so what we find a lot of times for, facilities that have health and safety teams, involved with this, when they see the SDS of PLM403 compared to IPA, they're begging for this solution to come in-house, so they don't have that risk associated. We had a lab sometime last year, Burns Dental, over in Europe, and they actually had a little bit of land with their facility, and so they had sheds all around the lab where they would store their IPA, their fresh IPA. They would store it in there, and then have different sheds that they would store the used IPA when they were waiting to have it taken away, because they didn't want the risk of having it in their actual building with people nearby. And then we've talked about the detergent longevity. Some of the pieces of, the benefit of this are that, reduction in manual labor, a reduction in time, but longevity, we see that PLM403 will last 10 times longer than IPA. And you can see it on this chart. We've done a lot of different testing with different, chemistries. Right towards the bottom, you see the light blue line, that's IPA. And so that's why labs have to switch this out so frequently when it comes to saturation. And then the line up at the top, the gray line, is the PLM403. So you're able to, staying within that 10-minute cycle time, clean many more parts there. And so it's not just, for every, 1 gallon of PLM403 you're using, you have to buy 10 gallons of IPA. That means you also have to get rid of 10 gallons of IPA for every 1 gallon of 403 that you're using. So the cost is multiplied on the acquisition of your IPA and having the waste being taken away. So here's a sample ROI, Mike, if you want to.
Yeah, so a cost analysis is pretty standard. At Proto3000, we want to make sure that, there's a reasonable return on investment for any piece of capital equipment. So in this case, we took their numbers for one of the labs that we spoke with about what their regular usage for IPA was over the last year, what their cost per liter was, what their cost was to dispose of it. So you can see there, $3,000 for cost of IPA, about $7,500 for waste removal. And we did the calculation live with how much time was being wasted. You know, the whole concept of the detergent not needing to be replaced as frequently, like if you're talking you're high volume, maybe 6 months. If you're maybe somewhere to like mid to low volume, if you can go a year without having to swap the detergent out. Having to constantly swap the IPA out once it becomes overly saturated, there's a cost to that. Having your tech swap it out, it's labor, and it's just a waste of time. And so this lab in particular was wasting about, you know, a little over, you know, 10,500, a little under 10,500 a year. So this was, I believe, with 4 printers, 3 or 4 printers, if I'm not mistaken. So there's definitely an argument to be made here for the cost savings, because we sat down and very intensely calculated these numbers. It was a very intense cost analysis meeting. We were debating some of the things, but this is the number we came out to the end. The other thing is, we're happy to do this with any customer. So if at any point you feel like this is something you want to see, we'll absolutely do the calculation with you. And we'll show you everything just so you can make an intelligent decision for your lab.
Mm-hmm. Yeah, so you know, we have labs that have 1 or 2 printers that are using a post-process solution, and then we have facilities with 90 to 100 printers that are using you know, our solution. They need a couple of different, you know, a couple demis in there to keep up with that that throughput. But it really, you know, even from a low end perspective, mid, and then a high end perspective, numbers usually make sense, and the safety aspect of it is great. And there are some additional savings that aren't captured in this ROI, but you know, just for simplicity's sake, this is a pretty good way of looking at it. And usually we see it's usually anywhere from like a 14 to 18 month. That's kind of a common range we see for dental labs when it comes to ROI. We've seen some as low as a few weeks, you know, some over 2 years, but that's the general range. And just one quick note, this is biocompatibility approved, 10993 standard. So that's anything with prolonged contact with skin and mucosal membranes for up to 24 hours. And so that is cleaning in our PLM403 in the demi with a rinse afterwards, either in water or IPA, if you want to do a rinse to get it dried faster. So you can do either way there. It is not currently, we haven't done the testing for dentures where it'd be, you know, in the mouth for a longer period of time. But that's something that's hopefully coming soon. But one other note here, as I mentioned, the rinse after our Demi 430 or after that step is either in water or IPA currently. We also have an Aux 400, which is a third option for rinsing, which we have a lot of customers in the industrial space using this for the rinse step. Basically, it's still safer than IPA, but it dries faster than water. So we have customers using this for the rinse, but it's in the process of the biocompatibility testing for dental and medical applications. So stay tuned for that. That hopefully should be you know, something that is confirmed either late Q4 or early 2024. So just a quick recap. This solution improves, you know, the safety of, you know, your facility and your lab and like everyone in your team. It's a more sustainable solution, lower energy usage. The, you know, chemistry usage is significantly lower, both on the acquisition and the waste side. You're still able to use it in biocompatible situations, and the productivity gains are what, you know, wraps up to make it a good business case to bring something like this in-house. And as I mentioned, we do a lot of testing in-house, and we have a lot of partners that we work with that do testing as well. So we're partnered with a lot of the resin manufacturers as well as printer companies. So we have a qualified resin list that this list grows usually every month of you know, more materials that have been tested in our solution. And in order to qualify it and validate it, we test that at our facility. We have the manufacturer test it, and then ideally have customers testing it. And then we do the mechanical testing and evaluation on the material to make sure that the results are the same as what you would expect with any different cleaning method.
So I don't see Key Splint Soft here, but that one's a really popular one that I know a lot of labs use. And also, don't think it was covered earlier, but you can mix the different resins in here. So if you're printing a build tray of surgical guides, night guards, models, chuck them all in. They are all capable of being washed in the same bath. I know that that's something we do in the back here. If we're doing a batch of jobs, we switch them out by application, but that's something you'll no longer have to do with the post-process.
Yeah, absolutely. Yeah, that's a really good point. And then, one of the questions that usually comes up that I didn't cover is, if we're running biocompatible resins, do we have to run that exclusively in this machine, or can we clean other parts at the same time? The answer is yes. So during biocompatibility testing, we ran a lot of non-biocompatible resins at the same time, just to confirm that the end result was good. So you can mix and match those, as Mike said, as you're working through there. So that brings us to the end of this presentation portion. So we will have a little bit more of a talk with the team from Schell, which I'm excited about. So yeah, Jamie and Evan, obviously we gave a little bit of an intro earlier, but I know we've had some more people hop in to the webinar at this point. So if you want to give us just another quick little recap of your lab, and why we're sitting here today.
Sure. So yeah, we're located in Kelowna, BC. Mostly Crown and Bridge, and mostly digital at this point. The transition to digital has been super strong here in our office, and keeping up to the changes needed to keep up to those digital workflows has been constant. So we're constantly changing, and this has been our latest addition to it, trying to streamline our workflows and focusing on the health, safety, and environment aspect. Again, like you said, was our initial focus. All the other things, and you guys covered almost everything on my list here, but are just bonuses compared to the safety thing for us.
Awesome. And Evan, so I understand you're working more day to day with the machine now, right? You've been with Schell for a couple of years, and so if you want to talk a little bit about what you were doing in terms of cleaning before the Demi 430, and then how long were you guys looking for some alternative to IPA to cleaning?
Yeah, for sure. Kind of as Jamie pointed out, we're kind of always changing things. We always have our eyes open to new technology, and kind of as you mentioned earlier, there was always kind of a bit of a black box as far as post-processing and how to deal with the parts coming off the printer. So we were doing a very generic IPA clean before. So we had a two-step process where we basically had an IPA agitation tank. So we would do a first dunk in the IPA, get most of it off, and then we'd have like a fresh bath of IPA that we would do a second agitation with, and basically air dry from there before curing.
Gotcha. Okay. And one thing I think you had mentioned before was the process, so the frequency of IPA swaps there, and what goes into, because that's one thing that I think is often forgot about, regardless of the industry or lab. But what goes into when you're switching that IPA, and what was the frequency you were doing that before?
Yeah, for sure. So as you said, IPA gets saturated pretty quickly. So we were definitely noticing that you can find yourself pretty frequently putting parts through your IPA bath, and they're coming out and they're not clean. So we were doing a IPA change basically weekly to get a fresh bath in there. And then you guys covered the financials pretty good about the cost of IPA and everything, but one thing that I noticed is there's quite a bit of labor involved with actually doing the swap of the IPA. So it takes quite a bit of operator time to take out the old stuff, clean the bath out, and then obviously put the new stuff in, bring the old stuff out for disposal. So definitely a lot of time involved in doing the swap.
Mm-hmm. Yeah, absolutely.
For sure. And comparing an agitation bath only compared to having all three heat, ultrasonic, and agitation. Sometimes with new IPA, an agitation bath will work for regular parts. As soon as you get more complex geometries, implant models, things with holes, that just the current of the agitation doesn't really follow through. That's where the big difference with this machine is. And the consistency is, between the size of the unit, the volume of the material. Everybody knows that 3D printing is the weak link in the system, between the accuracy of the models and no one talks about the consistency needed to create accurate parts. It's not just buying the best printer on the market. You can muck it up with all the extra steps you got to do. And you're right, no one talks about the post-processing. The industry, if you haven't been printing, feels like you send your files and the parts come out. That's definitely not the way it works. And some of us that have been in the lab for a long time know that running a plaster room is probably cheaper and easier in ways than running volumes of printing. It's hard to get streamlined and to do well.
Mm-hmm. Yeah, that makes sense. Yeah, you have so much experience in the industry that you've been through. You've like firsthand experienced the changes and like shift in the market in that way. So over the years, have you looked at other methods of post printing to try to get away from IPA in the past?
Evan, you want to talk about that, or do you want me to?
I can just add a little bit here. We've definitely tried a couple different solutions as far as cleaning. We've even tried actually changing the resins that we're using to print, but nothing seemed to really have kind of any huge game-changing benefits as far as changing the material we were using. Just a quick note with the Demi system, we're actually cleaning the whole build tray at once, as you said. So that's had a huge benefit for us as far as time as well, is to just throw the whole build tray in there, and we're not cleaning that manually anymore. And even with the excess material that we're actually putting, the excess resin that's left on the build tray that we're putting in the system, we haven't seen a big change in the actual saturation level of the liquid, so that's a huge benefit.
Yeah.
Even handling the the trays with all the resin on it and trying to cut your parts off, it's just messier. There's more opportunity to get it on yourself, and we're just washing it all. It was a concern for me. I'm thinking, man, that's a lot of material going in. But so far, it's been a couple months, and it's almost not even registering. And we're doing 200 to 300 parts a day. There's lots with the whole tray going in. The build trays are fairly big. 3 trays we built our own hangers that we're just hanging in there, can easily go in there. So there's lots of material going in there for sure.
Yeah, 200 or 300 a day. Yeah, that is. I'm glad to hear that the longevity is where where you'd expect it to be, and it sounds like there's a lot more life, especially in your detergent bath. And so, like what Mike said earlier, usually we see anywhere from 6 to 12 months before even the smaller system you have to swap out that detergent. So yeah, a couple hundred parts a day, even down to just recently we had a lab that was doing 20 to 30 parts a day, and they went with the Demi 430, and partially for the safety aspect, partially because there was cost and time savings. But they know that they're doing 20 or 30 parts a day right now, but in a month that might be 50 parts. And so you're at 200 or 300 right now, you might be at 500 parts a day down the road. So just knowing that you have the capacity to do that, and you don't get worried if your volume increases, can be helpful there. That's awesome. Well, you guys, thank you. I appreciate it. I'm going to ask you to stick around. We have 7 minutes left here, and we have some questions that have popped in. I don't, unless you have any other notes or thoughts, Mike, before we switch over to some of the Q&A.
Yeah, one thing we didn't cover in the presentation, this came as a request pretty specifically from one lab regarding the accuracy. So once we get our DEMI 430 installed in the back, we're going to be doing a tolerance report. So we'll be doing 3 separate batches of prints. We'll be separating each build plate in half. So half will go to IPA, half will go to the DEMI 430. We're going to post-process them normally based on the manufacturer's recommendation, and then we're going to scan all the models and overlay them onto the original STL file, and we'll share the results of the accuracy. This is something that we also want to prove out. So every stage of whatever we're trying to do with like health and safety or productivity, we want to proof it out here as well. So we'll have, we don't have the tolerance report yet. I would have ideally liked to have presented that today, but we'll have it for anybody that wants it. You're more than welcome to email us afterwards. We should have it maybe within the next 2 weeks.
Yeah, so the bullet points there: safety, sustainability, throughput, and then tolerance, accuracy. That makes sense.
So I'm going to go through the questions now. I'll you want me to fire them off? Okay.
But
do you have a PDF of this meeting with the information about IPA and such to use to present?
yeah, so yeah, in order to be able to present this information internally, so we can, I think we will probably be sending out a recording of this. Yep. Just my guess, or that'll be a link that's available, and we can send out a PDF of the presentation as well. And we're our information will be on this as well, so you can always email us, Mike or myself, to connect about this, to have kind of a more detailed discussion about your application specifically.
Okay. What is the process of changing out the liquid?
I would have Jamie and Evan talk about this, but they haven't had to do it yet. So yeah, it's pretty simple. So you have the internal tank there. There's just a low point drain in the system, so you can either use that to drain the system out once the detergent is fully saturated, or we have some customers that just use a drum pump to pump it out. Either method works. It's a 10-15 minute process of draining it out, and then you can just refill with fresh detergent.
Okay. Is there a defined time frame that must be followed between printing and post-processing?
That's a good question. So there's not a specifically defined time frame, but with any resin printing, the moment you print that part and you have uncured resin that's exposed to air, heat, any UV rays, it will start to cure up. So the faster you clean off the parts, the better. You'll just have better results. With the caveat, I will say, a lot of labs we see will be draining the tray a little bit, letting it drip dry somewhat, just so you're not putting all that resin in. So within a matter of hours is usually the recommended time. Waiting overnight is the maximum any would ever go, I think, with cleaning the resin.
You can mix non-bio and bio resins.
Yes. So the in the same bath of detergent, you can put in something that's like a high temp amber that's not biocompatible with some sort of biocompatible material. So you can clean those in the same bath, which is one of the nice benefits there.
Can you use the PLM 403 with the ultrasonic cleaner we have?
Mm-hmm. Yeah, it's a common question. So can you just throw this detergent into another system? The answer is you can try it, but the PLM 403, the detergent that is used in our systems, like I mentioned, it's designed to be used with the DEMI systems, which control the temperature within certain ranges to clean the parts most efficiently. And depending on the resin, for more viscous resins, you definitely do need some added temperature. So that might be up to 100 or 110 degrees Fahrenheit. So if you have a bath with all of those things combined, which is relatively rare, you can try it. But generally, it's a full package solution that people use for.
What about post-processing delicate pieces like printed partial frames?
Yeah, so a couple nice things about the Demi for delicate parts and then also small parts. There are a lot of different ways that you can fix your parts. So, just in the last couple of months, obviously at Schell, they've come up with some ways to put in their own build trays and clean all the parts at once. But we also recommend for very small parts, you can clean parts in like small bags. And so for extra delicate and extremely small parts, we have customers that will use nylon or Teflon mesh bags. And so you put the parts in there, they stay together. You can run a bunch of different batches at once within different baskets that we offer. So those are some of the options out there. But we have a large basket catalog that can be reviewed, and we can talk about your specific application, what makes the most sense.
We have 3 Stratasys J5 printers. Does the Demi 430 work on that material?
Yes, it does, but there is a different detergent that is used for polyjet spore removal. So that's something I see is Jeff. We could hit us up after this, and we can talk more about that specifically. It looks like it's 2 o'clock. I think we're probably okay to take a few minutes extra to answer additional questions. I don't know how the Zoom works out.
It's not kicking us out yet, so I think we're still okay. What does the changeover process look like for the detergent? Is it automated or manual? Okay, so you answered this a bit earlier. There's a drain at the bottom.
Yep.
There's a drain at the bottom where you can pump it out. Okay. Would your chemical be useful in standard agitation bath? Okay, so this is the same question again with the what is the approximate equipment cost for the machine itself, and is it lease or purchase? So for us as the vendor, yes, you can lease or purchase it. Like we would cover that with you. Do you want to cover the cost of the machine?
Yeah, sure. So the Demi 430, which as we talked about is the most common one for dental labs, it's about, so this price includes the equipment, the machine, with the baskets that you put the parts in, the detergent that you start out with that will last 6 to 12 months, includes the warranty, and install and training. All together, that comes out to about $25,000 US. And that can be, purchased, can be leased, and actually we have a deal, through the end of the year. So some financing options where you can do no payments until 2024. So you can get the benefits of using this solution, cost reduction, the safety side of it, especially through what can potentially be a busier end of the year, and then not have to make any of those payments till next year.
Okay. And the last is the polyjet detergent compatible with regular biocompatible resins as well?
So we haven't done that testing in-house on polyjet parts specifically, but we have quite a few customers that are doing polyjet parts, and then you can just do the biocompatibility, like biocompatible accepted workflow after you clean the parts in our system to make sure that they are approved for that.
Can you touch on Emerald Care?
Yeah, absolutely. So with the Demi systems, we offer service plans and care plans for the machines. So you can add additional care plan years. The first year is included. And so for additional years, we have Emerald Care and Diamond Care, where basically you get a full warranty for parts and labor for additional years, and then a PM visit included in that calendar year as well. And so that PM visit includes just checking and maintaining maintenance of any potential wear parts, as well as swapping out your detergent for you, doing a deep clean on the system, and then updating the software on the machine to include any additional software updates. We usually every 3 to 6 months we have software updates based on customer feedback of what might be helpful in terms of the use of the machine.
Is it 110 or 220 volts?
The Demi 430 is 110, and then the larger machines, they can be 110 or 240.
Perfect. Okay, so I think that concludes all the questions, unless anyone has any other questions before we hop off here. Okay, nothing's coming in. So I want to personally thank Jamie and Evan. You know, if you're a lab tech and you're on here, you know that we kind of stay behind the bench. We don't really like doing these public talking engagements. So I know this is a big deal for them. Jamie's brother as well. Jonathan is also very shy, so I don't think either of them wanted to. But they're champs. They came on here. They were very helpful in giving their experience and sharing it here. And I'm very appreciative for both of your time. Thank you for that. And John, did you want to say anything before we hop off here?
Yeah, no, I think you covered it. That was awesome. Jamie, Evan, it was great to talk to you. Mike, I appreciate all the support. It's been, it's great working with Proto3000 on this. So yeah, and I'm sure we'll have some follow-up calls and emails on this. So anyone feel free to reach out to us directly for more application-specific questions.
Yep, and we'll have a recording of this made available. So if anyone wants a copy of it, we'll have it edited and sent out afterwards. So that concludes our webinar for today. Thank you so much for everyone attending, and hope it was valuable for you. Thank you.
Awesome. Thanks, guys.
Thanks, guys.
Okay. See you later.
Cheers.